lucky enough to also have one of the seniors that's going to take over, Andrei Krijan, coming all the way from Sombor in the Novi Sad office to work on the back end. And this is one of the most brilliant developers I had the privilege to working with. And Andrei, with no further ado, if you are here, buddy, the floor is yours.
Hello, people. Thanks for the very nice introduction. Okay, so I know this is supposed to be a MedTech talk, but because I had a really great team, I didn't have any, MedTech specific challenges as an engineer, because all of those specifics would still come to me in, the form of a feature request. So all I had to do was just focus on being a good engineer. And the other, specific things which are required for, those more serious systems, I urge all of you engineers to always perform them in even a silly dropshipping system. So to me personally, coming from like 6 other domains before this project, I felt no difference in the MedTech. So I'm going to take this opportunity to actually talk about my takeaways during this whole project, the things I learned as good practices as an engineer while working with this team, with a uncertain client, and also working on multiple projects concurrently in the HTEC. So let's start. Should I take control? Oh, I should not. Okay. So, sorry, I have 3 topics to discuss. So, keep your tools sharp, or tooling, question business logic in order to improve it, or product ownership, but in a different kind of sense, like know your domain and know your code, know your business logic, and finally write adaptable code. So let's get through this. So keep your tools sharp. And this is the first thing I learned here, because I started working on this project and the JDP and some other tech excellence projects. So in order to help out my pupils and to help out myself, it was imperative to me that I don't spend redundant time doing things I already solved. So once you solve a certain problem and you see that it can be repeated, let's start at the smallest granularity. Let's say you have in a service, you have a thing that needs to be done twice, like get the user and throw an exception if there is none. So instead of having duplicate codes, you abstract it to a private method. Cool. Then you found out there's like a functionality that needs to be repeated across services. Okay, you create an internal service. Good. Then you find out, okay, there's a functionality that needs to be repeated through the whole solution, which is domain specific. Okay, you extract it there. And then finally, the best scope, the scope I like most is the common scope, which is like, this problem is not specific to this domain at all. This is a problem that is going to repeat itself in multiple projects. And I don't want to be asked to always, solve it from the beginning. So what you do is you notice that and you scope it to the appropriate reusability level, so you can reuse it. And in the final step of this project, I ended up creating like 5 nugget packages, which I distributed to my pupils around JDP and to my other projects. So I can, if I improve the thing I'm solving in any way, it's going to get just redistributed into all the projects, which is nice. So let's see some of the examples of it. The first one was, I'm guessing all of you, or most of you, from C# engineers know about the anti-framework, and probably whenever you make a system, I think in like 99.9% cases, you're going to need a functionality that gets you a page of something. It's boring. It's really boring. You see on the left side, there's a lot of validations, like to check if the page size is okay, the page number is okay. There's no constrained errors, and then you need to get the total count of the filter you're trying, so you know how many pages there are, and then finally get this exact page you want. So what I did was just make a extension, which is basically convert the whole query into a page, and that's it. And I just give it the concrete parameters. The idea of writing tools, good tools, is to decrease it to that level that when you need to do something, the other way around, that when you have code, the thing you write, the thing that's changeable, it should be meaningful. So I don't want any boilerplate anywhere. So always it comes down to one line, which has discernible arguments like this to page async, which solves it. There's other examples like I didn't want to constantly break with my ifs to have a condition, so I made a conditional where. So the end result is what my colleague Darko used to call a senior's code, which is when it's the whole code is in an arrow function. There's no brackets. Then the last example, the orange one, is also a boring thing, because if you want to order something, and usually it's an argument, the direction of the ordering is an argument that comes from the front end. It's not a static thing. But the NT-framework and the LINQ code in C#, it doesn't allow you to give it the argument of which direction you want to go, but you need to, depending on this direction, you need to call either order by or order by dests. So I just made one which says set order. I give it the direction. And then the other thing, which I noticed, I need to allow the client side, whoever is calling my project, to tell me how they want to order it. So I just ended up having enums for every repository, for every entity, which says, you can order this entity by these properties. And then I didn't want to have a bunch of ifs or a huge switch. So I just inlined it all in one line of code again. So you just said, set the order of this query to this direction and order it by this enum, which points to the exact property you want, which then gets injected into the link queue below. That's one example. There's multiple other cute examples, which I'm proud of. And you should be proud of if you write a good thing that needs to be reused. So like this distinction, there were lots of places where I needed to ensure that the thing I'm getting is really distinct, the values, the IDs, and it became really boring with that, because that's usually like 5 lines of code. I need to make sure that, I need to make sure that it's distinct, and also to get the duplicates so I can print out a proper message. So this is what I came up with. So just tell it this needs to be distinct, and it gives you an option to create a message dynamically. It just gives you back, if there are duplicates, it's going to call this function, which creates a string, and from the duplicate collection. So it's quite easy to use. The point of these tools, the huge benefit of this, like I have a great example which I did not include because there's nothing to show actually, is that once you discover or identify that a certain problem is common and can be reused, you can at that point make it. Oh, someone stole the control away from me.
No worries, no worries. I'm gonna get it back on the screen. You just continue the talk.
So the beauty of it, if you discover, this is a thing that can be repeated and will be repeated. I have a good example of it. Like I needed to, I have a sorted collection and I want to insert one item into it. And I know that can be done efficiently if I do a binary insert, but I don't want to write a binary insert on that level. So what I did is just create an extension, sorted insert. But I was lazy and I didn't want to actually write the binary at that time. But that is good. I identified it, I extracted it, and now I have a sorted insert, which actually did nothing to improve it basically just inserted it and then just sorted the whole list, which is, there is no optimization there. It's absolutely horrible. But the good thing is I extracted it, and for the next year I forgot about it. But the code works; it's fine. But the beauty of it is that I know that it's there. The extracted function is there, so I used it in like 30 places. And then when I finally got around to implementing the binary insert, I just needed to implement it in that one place. And in 30 use cases, I got a speed up. So that's like a staggered tooling kind of thing. But that's my way to tell you it's okay to not do everything all at once, but just identify what you want to do, separate it, and then you can improve it incrementally all the time. Like with this requires distinct, with this with almost every of these tools I'm showing you, I think I have like 5 to 10 versions of them. You first write it, and then it clicks, oh, this should be more flexible. I need to add more signatures to it, or I can improve it, or a C# update comes along and it does it in a better way. So you add it. So that basically just the single responsibility principle in practice. Just separate one concern in one place and perfect it at that place. The other thing I'm really proud of is we needed a filter, which is basically a string filter. And it's just a string from the front end, which contains multiple words. And the search needs to work like, if every word in the string it matches the certain fields, then it's correct. The entity passes the filter if the selected rules will the entity have all the words in the filter. And it was also really, really boring and hard to implement by hand. But then when extracted into a tool, which does a lot of magic, as you can expect by looking at it. Like this is one line of code where just, here's the filter and here are the rules. For this filter to pass, or for any patient to pass this filter, his first name or his last name need to start with the words in the filter, or the identifier needs to contain the word in the filter. And it's just a beautiful line of code. And then later on, I improved it by like making it a Google-like search, adding like you can quote phrases and blah, blah, blah. So, and then this is the example of the set order thing when I needed to implement another signature, which allows it to be ordered by multiple fields. And let's carry on. I'm going to steal the control again. And the grandest tool I made during this 1.5 year was we needed to work with the HDF files, so medical structured semi-database files. It's a fucking nightmare. And the underlying library, which existed, because it's not a popular tool nor a popular structure. For the C#, there was only the HDF invoke, which just basically calls a Python script underneath it, and it had a horrible interface. Like for this line of code on the left, you can see there's 3 lines of code, creating a group inside the file with 2 attributes, comments, and description attributes. Then inside the group, it creates a data set of timestamps with a collection of data with attributes, interval unit, and the same for the next data set. To do that in that library, it would take around 100 lines of really goddamn complex code where you need to open everything, take its ID, check if the ID is actually an error message. Then for each data you want to add, you need to create a type for it, then create a data space for it where it's going to be written. Then keep those open until you write them, but not close them before you close the data set is being used on. It's a mess. And so the first time I was implementing this, because as it says on the right, we knew we were going to have 4 types of HDF files we need to support, and those are complex structures. This is just like one method to do one part of a Fitbit recording HDF file. So we needed I knew it's going to be a lot more of that where that first one came from. And I knew it's going to be like 10,000 lines of code if you want to do that. So what I did, which is thanks to the great team I have, is I told them that, hey, this is going to be hell to maintain. This is going to could be hell to change, because also we're working with a client who doesn't yet know what their system is supposed to be like. So in order for us to change it when they need to change it, and when we hit something which we shouldn't hit, I would like some time, if you can box it out with a client, so I can actually make something usable. So when I leave this project, no one needs to call me like in 5 years to say, what the hell is going on over here? No, I want to leave a succinct code. As I said before, every line of code must have a purpose. Like, it must say, I want to do this. I don't want 50 lines of code doing one thing because a library forces me to do it. So thanks to my team, I said, yeah, let's check the client. The client said, okay, the feature is not blocking. It's like at the end of its use case, it's just exporting the files. Sure, we can do it whenever until we have the project done. So we pushed it back. And whenever I had the empty space, which we would look for it, we took like 2 months where we would allocate 20 to 50% of my time in a sprint so I can work on this. And I'm goddamn proud of it because now, as we predicted successfully, it had like 20 changes in how it works. And that I think I would have left if I had to change that huge initial code 20 times. So this is just a beautiful example of when to use tooling. When you see you can make someone's life easier and you can speed up the production. I mean, when you look at the statistics, it was a great call because we saved a lot of time and a lot of mental stress. And for the technically curious, the library is like a wrapper on the Python. It uses a disposable pattern, so you can see that I start by using statement on the group. So when the method closes, it closes the group. There's like a subscription model inside every HDF object, which is my class, which remembers who's using it. So it knows when it's allowed to close. Because if you don't close everything, it's going to be a corrupt file. It's a mess, as I said. It's really, and then you need a lot of flexibility because you needed to have possibilities of multiple attributes on any object, which, as I said, one attribute, in order to create it, you need to create an attribute inside that object, then create a data type for its name, to use the string as its name, and for the data set, just to write the name. Then you need to determine the type of the data you want to put to make the type, to make the data set, to write it in. And the same for every data you want. And I needed to be able to have data sets with single data, collections, and matrices, for example. So that's all in there. And every of these create data sets has like 20 signatures, which allow different types of, is it a single data entry? Is it string because string is special? Is it a generic type, which then takes the type and figures out how to create the HDF type for it? And the thing I'm most proud about is you can see the attributes are actually just parameter tuples, where you just say, okay, I'm creating a group and it needs to have these combinations of attributes. We just get converted into it instead of writing 50 lines of code for every attribute. So that's tooling. And I know I might be bragging too much about it, but I'm proud, and you should be proud if you do these things, because it's going to help future developers, yourself, and you can use it across multiple projects. You can educate people easier. Thank you. And so that's about tooling. And as I said, that's the thing that I learned a lot about on my HTEC experience here. Next. So the next thing, which I love to do, and which was important here because the client wasn't even sure what they wanted. So as an engineer, especially on the backend, you're going to be the one who is the closest to the business logic. And you are the one who has the greatest responsibility to detect if the business logic is going to be harmful to your system or harmful to your users. So I have a great example here. The text here is, for reading data, but basically is what I'm talking. I don't like reading presentations. But yeah, you need to understand what the client actually needs and wants, and to wait if the worth of what he needs, or he thinks he needs, or he wants, is the worth the cost of the technical depth you're going to have to bring to it. And you're not going to make thankfully, you don't have the pressure of making a decision. You just need to identify it and tell it to your team. Hey, yeah, we can do this. Like 95% of this is fine, but this 5%, this thing which the human client thinks is easy because it's easy for humans, but as you know, often for computers is different. Like you can teach the computer to be the better at chess than any grandmaster in the world, but that's much easier than teach the computer to see the board in front of it. But the client doesn't know that. So you're the one who's responsible to say, hey, what you want is not really great. So to cut it short, sorry, the example here was that the client wanted 3 or 4 separate pages, like this was 5 separate functionalities and user responsibilities, where the clinician, their initial idea was that the clinician should enter and maintain surgeries on one page. Then on the other page, enter and maintain the devices in the patient. Then on the third page, enter and maintain the leads, which are a collection of electrodes. Then on the fourth page, enter and maintain visualizations. Then on the fifth page, configurations for recording and using it. And that was just a nightmare to me. Like there's so many edge cases or validations that you need to now cross-reference, which is hell. And also for the goddamn clinician, like he's not the one that's personally doing the surgery. He shouldn't know every detail. He just needs to, like in his real world, which you need to mimic, he just gets, okay, this patient had this surgery and it did that. So we did that. So we changed it. Also now again, thanks to the great team I have, we took like 2 weeks where we would 2 times a week we would dedicate 1 or 1.5 hour grooming sessions on how to suggest a better solution for the client so they can accept it, because you can't just go to the client and say this is wrong. No, they don't care. You need to give them a better alternative. So shout out to the now father Nicola, who stuck by me. Like those were 2 intense weeks, and we just created a 1 page when the clinician just enters, okay, a surgery happened, it did this, and it just does a stateful, check. It's a state machine now. It checks if that's possible. Can you remove something if it isn't there? Can you add something if it's already there? Does it conflict in a way? So it's just one action of recording what happened, and the system does the rest for you. It makes displays, it orders the things, it even creates, the history, so you can jump back and forth. So the system helps the user, not makes the user have great responsibility. So that's my takeaway here. Make the system as you would want to use it. And the final thing I want to talk about, adaptable code. So there are 2 currents in being an engineer. You want to write code which is going to last forever, which doesn't need to change. We want to write ideally perfect code which can work for the next 100 years or until the business stops needing it. But also, you need to write code that can easily be changed when it needs to be. So those are 2 conflicting ideas, and these are some of my takeaways how to do it. Basically, it's kind of contained in all the previous points I did, but take time when you work on something. Actually take as much time as you actually need it. Communicate that to your team and say, I want to do this right. I want to do this now and never again, so that it is at the same time great performance, but also it reads like a book, so I can forget about it tomorrow. I wrote it and I know that I've separated very nicely what the intent of the code is and what the solution of the intent is. So if you run into a technical problem like bottleneck, you need just to change the solution to the problem. But if the client needs to change the feature, then you need to change the intent. And important to whoever comes to read it. Doesn't just see a big blob, which is a mixture of those two things, but sees, okay, this solves this in that way. So I can change the way that in which it's solved, or I can change what it solves, or both. And that's basically it.
We need to speed up. We got
sorry. One more point for the end, to help you do that. Imagine that every layer of code you're writing is an API, and the next coder who's going to use it is your user. I do that with myself. I was the sole programmer here, but I wrote every layer as if someone new was going to come. So you need to make it flexible enough for the technical purposes they need. You need to restrict them so they don't do anything stupid, don't do anything they don't need to do. But if they need to do something, you need to allow them plenty other ways how they need to use it, like make it as acceptable of technical solutions as possible. Thank you for your time. Sorry for taking too much of it.
Thank you, Andrei, so much.